Hi friends, welcome back to Civil World YouTube channel. Dear friends, in this video tutorial I am Sambat showing you here very important topic for today, STAAD Pro introductions. I already shared this content in Tamil language, so Tamil viewers and subscribers, you can view this video on STAAD Pro Tamil playlists. I shared the Tamil STAAD Pro video link in description. Remember, for more video you must like this video and subscribe this channel for getting notification. So don't forget to like and subscribe this channel. This is the STAAD Pro icon. This is the STAAD Pro homepage. This is the menu bar. These are all the project tasks. Here recent files, help tips, license configuration, and have STAAD Pro live news. In this project task we have new project, open project, open the project wise, configuration tool, backup manager, license management. First we set up on configuration tab. Here we have two unit systems, one is English system and another one is metric system. First, English system means including of inches, feet, foot, pound and kilo found and etc. Second one is metric system. Metric system include meter, kilometer, millimeter, kilogram, etc. Click here to change the units before opening the new project. Next, go to STAAD Pro default design codes tab and choose steel, concrete, aluminum, timber, shear wall design codes as per your design. Structure type: space used for 3D modeling, plane used for 2D modeling, geometry, loading and deformation are restricted to the global XY plane. Floor similar to plane but geometry is confined to the X and Z plane. Truss used for creating truss where all members are defined as truss members. A truss structure carries loads by pure actual action. Truss members are deemed incapable of carrying shear, bending and torsion. Change file location. It recommended to create a folder for each model you created because STAAD generates many files. This is the STAAD Pro graphical user interface. This is the STAAD Pro icon. This is the menu bars. These are all toolbars. This is the working area. This is the data entry area. This area allows for manipulation of the model view. The yellow isometric cube change the face viewform. The other buttons rotate the model. You can also rotate by right click and dragging. Select cursor used to change between node cursor, beam cursor, plate cursor, etc. Page control. The organization of the pages from top to bottom represents the logical sequence of the operations. Main window where the model drawings and results are displayed. Data area where different dialog box, tables, list box, etc. appear depending on type of operations you are performing. This is a geometry tool. Here insert nodes manually by defining the XYZ coordinates. Here this is the drawing tools area. Add beams, plates, surface, solids and snap node and beam, insert node, generate surface mesh, all are included. This is general tab. Property: define properties for the elements you create, cross sections, W shapes, plate thickness, etc. Also create beta angles, element rotation also. Next, specification: define member releases, offsets, truss members. Next, supports: define supports for the structure, pinned, fixed, rollers, linear or non-linear springs. Next, load and definition: generate load case to define nodal loads, member loads, area loads. Load generation can be created for moving loads after defining a vehicle. Material: define new materials if structure use something other than default materials: steel, concrete, aluminum, stainless steel. This is the analysis and print tab. Analysis: add the command perform analysis with no print. post print. Define the commands desired for your output file. These are seen in the tabs above. After adding the commands, assigning them to the members you want the results for. This is the post processing tab. Here node displacement and support reactions, beam forces like axial, shear, moment and stress, etc. Animation, view the model animation of the displacements. Reports, create a custom report with the desired inputs and outputs for desired load case, members and loads. The pyramid is the 3D render view and the drop down menu is the load case selection. Turn on shear and moments diagrams to view in the main window. Left STAAD editor for the manual coding. Right output file, unit adjustment, symbols and labels, visual loads and dimensions, scale. Contents: Introduction to STAAD Pro, history of STAAD Pro, structures, type of structure, STAAD window, tools used, various type of cursors, page control in various modes, model generation, wizard, assigning property, supports, assigning loads, analysis, design, advantage of STAAD Pro. Conclusion. Introduction to STAAD Pro. STAAD Pro is a structural analysis design program software. It's included a state-of-the-art user interface, visualization tools and international design codes. It is used for 3D model generation, analysis and multi-material design. The commercial version of STAAD Pro supports several steel, concrete and timber design codes. It is one of the software applications created to help structural engineers to automate their tasks and remove the tedious and long procedures of the manual. History of STAAD Pro. STAAD Pro was originally developed by Research Engineers International in Yarmouth, Canada. In late 2005, Research Engineer International was bought by Bentley Systems. Structure. A structure can be defined as an assembly of elements. STAAD is capable of analyzing and designing structures consisting of both frame and finite elements. Almost any type of structure can be analyzed by STAAD. Frame elements, beam elements, 2 nodes. Finite elements, plate, 3 or 4 nodes. Solid, 4 to 8 nodes. In case of STAAD, node becomes joined. It has a number and XYZ coordinates. Beam becomes number. It has a number and node at its ends. Plate becomes a element. It has a number and node at its corners. Type of structure. A truss structure consists of truss members which can have only axial member force and no bending in the members. A plane structure is bound by global XY coordinate system with load in the same plane. A space structure, which is the 3-dimensional frame structure with load applied in any plane, is the most general. A floor structure is a 2 or 3-dimensional structure having no horizontal global X or Z. Moment of the structure, f of x, f of y and my are restrained at every joint. The floor framing of the building is an ideal example of the floor structure in global X and Z plane. Columns can also be modeled with the floor in the floor structure as long as the structure has no horizontal loading. If there is any horizontal load, it must be analyzed as a space structure. STAAD window. This is the graphical interface window as discussed. Various type of cursors, selection tools, nose cursors, beam cursor, plate cursor, surface cursor, solid cursor, geometry cursor. Page control in various modes. First one is page control in modeling mode. Second one is page control in post processing. This is the procedure for designing of building elements. First one, model generation and analysis. Input geometry, nodes, beams, plates. Input properties, input spaces, constant, supports. Input loading system, specific analysis type, run analysis, V1 verify results, design, verify. Model generation. There are basically three methods of generating a model: snap node method, coordinate method, copy paste method. Out of these three methods, most commonly used in copy paste method. By using these three methods, a structure of any geometry can be created. STAAD also constrains a command wizard, which it is library of structure such as frames, stresses, and present, which can be merged with the STAAD model. This is a run structure wizard panel. Assigning property. Assigning a property means to provide dimensions such as a width, thickness, etc. to beams, columns, slabs, etc. Next, supports. There are three types of supports provided to a structure: fixed support, pinned support, roller support. There are options provided in STAAD for pinned and fixed supports, while roller supports has to be created by releasing the f of x and emz components using fixed out. Next, assigning loads. Any structure is subjected to basically these type of loads: dead load and live load. Dead load includes the self weight of the structure, while live load consists of superimposed load. In addition to, structure is also subjected to wind and seismic or earthquake forces. While designing structure subjected to wind and earthquake forces, we also have to provide definition along with various load cases. These are the load definition and load items windows. After creating various load cases, we have to assign to the structure. For this, we have to first select that part of the structure on which load has to be assigned, and then assign it to that part. In case of structure substitute to wind and earthquake forces, wind and seismic definition need to be provided. After providing this definition only, the load cases should be entered. Analysis. After all the above stated steps, a structure has to be analyzed. Analysis of structure means to find out of the reaction and displacements and deflection at various nodes of the structure. After analyzing, we are able to see shear movement and deflection for each member. After performing analysis, another window which contains a report of analysis gets opened. This window shows the warning and errors which might have occurred. In the post-processing mode, we are able to see the reactions, displacements, deflections, shear force, and bending moments for various members. Next, design. After analysis, a structure has to be designed to carry loads acting on it, considering a certain factor of safety. In India, structure are designed by using various Indian codes for both concrete and steel structures. The design in STAAD supports over 70 international codes and over 20 US codes in 7 languages. After designing the structure, it is again analyzed, and the results of analysis for each beam and column is shown in the output file. Advantages of the STAAD. First one covers all aspects of structural engineering. Second one, broad spectrum of design codes. Third one, international codes. Fourth one, quality assurance. Fifth one, reports and documentation. Conclusion. STAAD is widely used by most of the organization for their construction needs. Unfortunately, well-skilled STAAD engineers are very hard to judge. If we believe in the prediction of the industry experts, then those students will be getting trained on the STAAD Pro in the current and upcoming 2 years. He have bright and successful career he had in the real estate and construction domain. By attending this training in STAAD Pro, we were able to learn various features of STAAD Pro, which will be very helpful in the near future. Thank you for watching this video. I shared the STAAD Pro introduction notes in description. If you have any doubts, comment below on comment section.